Good afternoon everyone. Today I am going to present before you how to find absolute term in binomial expansion and the applications of the binomial theorem. As you have already been taught how to find the binomial expansion for positive index. So let us recall that. So for a positive integer n, we define x plus y raised to power n as xn plus nc1, where nc1 is binary coefficient. It is called binary coefficient. nc1 is obtained like n factorial upon 1 factorial into n minus 1 factorial, xn minus 1y plus up to ncn minus 1 xyn minus 1 plus ncn yn. Similarly, we expand x minus y raised to power n as xn minus nc1 xn minus 1y and so on. So these nc1, nc2, ncn minus 1, ncn, these are called binomial coefficients. So from this expansion we can write the general term as, so general term in x plus y raised to power n will be, say r plus 1th term will be ncr xn minus r yr, and in x minus yn it will be equal to ncr minus 1 raised to power r xn minus r yr. So these are the general terms. These are r plus 1th terms in the expansion of x plus yn and r plus 1th term in expansion of x minus y raised to power n. So now our problem is to find the term independent of x, means a term in which no coefficient of x appears, no power of x appears. So let us consider the expansion of x plus a raised to power n, where a is some constant, say 1, 2, 3 or something. So what we do, we find its general term. So its general term will be ncr x n minus r ar. So we want to find the term in which no power of x appears. So what we do, power of x here is n minus r. We put n minus r to be 0. So we will get r to be equal to n. So the term independent of x will be n plus 1th term, and it will be ncn an. So let us see it with the help of examples. So suppose we have to find the term independent of x in the expansion of 3x minus 1 upon 2x square raised to power 12. So how will we find it? So we have 3x minus 1 upon 2x square whole raised to power 12. So first we will write the general term of this binomial expansion. So tr plus 1 will be what? Now here n is 12 cr. Now negative is appearing, so minus 1 raised to power r 3x n minus r, n in here is 12, so 12 minus r into 1 upon 2x square raised to power r. So this is the general term. So what we do, we will find what is the power of x appearing here, and we will put that to be 0. So simplifying this, we will get that this is equal to 12 cr minus 1 r 3 raised to power 12 minus r into x raised to power 12 minus r into, now opening this will be 1 upon 2r into 1 upon x square raised to power r will be x 2r. So we will get this to be equal to 12 cr minus 1r 3 12 minus r into 1 upon 2r into x. Now here the power of x is 12 minus r, here the power of x is minus 2r. 1 upon x raised to power 2r will be x raised to power minus 2r. So this will become x 12 minus r into x minus 2r. Now since the base is same, powers will get added, so this will reduce to 12 cr minus 1r 3 12 minus r 1 upon 2r into x 12 minus 3r. So this is the general term, r plus 1th term. Now the problem is to find the term independent of x. So what will we do? We will put this power to be equal to 0. So we put 12 minus 3r is equal to 0. So what will I get? This will give me r to be equal to 4. So that means the term independent of x will be fifth term. I put r is equal to 4 in tr plus 1. So I will get fifth term as 12c4 minus 1 raised to power 4, 3, 12 minus 4 is 8, 3, 8 into 1 upon 2 raised to power 4, and this will get cancelled. So I can solve this now. Now minus 1 raised to power 4 will be 1. What is 12c4? It will be 12 factorial upon 4 factorial into 8 factorial into 3 raised to power 8 into 1 upon 2 raised to power 4. So this will be equal to 12 into 11 into 10 into 9 into 8 factorial upon 4 into 3 into 2 into 1 into 8 factorial. So this get cancelled and we can simplify this. So fifth term in this expansion 3x minus 1 upon 2x square 12 will be the term which is independent of x. So let us recall that. So we have computed the general term. General term in this expansion will be 12cr minus 1r, 3x 12 minus r into 1 upon 2x square r. So we compute the coefficient of x here. It turns out to be 12 power of x. This turns out to be 12 minus 3r. So we put 12 minus 3r to be 0 so that we get r to be 4. So if I put r is equal to 4 in tr plus 1, I get that fifth term is the term which is independent of x. So after computing this, we get T5 is 12c4 3 raised to power 8 into 1 upon 2 raised to power 4. So let us do one more example. So suppose I have to find the term independent of x in the expansion of 3x minus 2 upon x square raised to power 15. So again I will compute the general term, say r plus 1th term. So this will be 15cr 3x raised to power 15 minus r into 2 upon x square r. Now here minus is appearing, so minus 1 raised to power r. So this will be equal to minus 1 raised to power r, 15cr 3 raised to power 15 minus r into x raised to power 15 minus r into 2 raised to power r into, now here I have 1 upon x raised to power 2r. So again separating out the terms without x and terms with x. So I will get this to be equal to 315 minus r 2r. Now here I have x 15 minus r, here I have 1 upon x 2r. So I will get x 15 minus r minus 2r, which will become x 15 minus 3r. So now the problem is to find the term independent of x, means I want the term in which no power of x is appearing. So what will I do? I will put 15 minus 3r to be equal to 0, so that 15 is equal to 3r. So r becomes 15 upon 3, which is 5. So r is 5. This means T5 plus 1, that is sixth term is the term which is independent of x in this expansion. So by putting r is equal to 5 here, I can compute that term. So T6 will be, equal to minus 1 raised to power 5, r is 5, 15c5 3 raised to power 15 minus 5, which is 10 into 2 raised to power 5. So this is the term which is independent of x. So we have considered this expansion. In this we have written the general term tr plus 1 like this. Then we have computed the power of x, which turns out to be 15 minus 3r. So we have put 15 minus 3r to be 0, so that we get r to be 5. So that the term independent of x in this expansion turns out to be sixth term, and this is equal to minus 15c5 3 raised to power 10 into 2 raised to power 5. And after simplifying this, I will get that this term is equal to this. Next, suppose I have to find the term independent of x in the expansion of 1 upon 2 x 1 by 3 plus x raised to power minus 1 by 5 whole raised to power 8. So problem is to find the term independent of x in the expansion of this. So again we write the general term. So tr plus 1 will be equal to, here n is 8 cr 1 upon 2 x 1 by 3 raised to power 8 minus r into x raised to power minus 1 by 5 whole raised to power r. So what we do, we will separate the powers of x. So this will be equal to 8 cr 1 upon 2 raised to power 8 minus r into x. Now x 1 upon 3 raised to power 8 minus r, powers will get multiplied. So we will get x raised to power 8 minus r upon 3. Now here we have x minus 1 by 5 raised to power r, again powers will get multiplied. So I will get this into x raised to power minus r upon 5. Now since base is same, so powers will get added. So this will be equal to 8 cr 1 upon 2 raised to power 8 minus r into x raised to power 8 minus r upon 3 minus r upon 5. So thus the power of x here is 8 minus r upon 3 minus r upon 5. So what was the problem? We have to find the term independent of x in this expansion. So I want to find the term in which no power of x is appearing. So what will I do? I will put this power to be 0. So put 8 minus r upon 3 minus r upon 5 to be equal to 0. So what will I get? So this means 8 minus r upon 3 minus r upon 5, I have put this to be equal to 0. So taking the LCM, 15, 40 minus 5r minus 3r is equal to 0. So after cross multiplying, 40 minus 5r minus 3r is minus 8r upon 15, this is equal to 0. So this means 40 minus 8r is equal to 0. So this means 40 is equal to 8r. So r is equal to 5. So thus r turns out to be 5. That means the sixth term will be the term independent of x. So putting there, I will get T6 to be equal to 8C5 1 upon 2 x 1 upon 2 raised to power 3. That's it. So this is the term independent of x and its value is this. So thus what we have done, let us recall. We have written the general term of this expansion, which will be 8CR 1 by 2 x raised to power 1 by 3 whole raised to power 8 minus r into x raised to power minus 1 by 5 whole raised to power r. Then we have separated the term without x, we have separated the terms with x, and the power of x turns out to be 8 minus r by 3 minus r upon 5. So since we have to find the term independent of x, we put the power 8 minus r by 3 minus r by 5 to be equal to 0, so that we get r to be 5. That means sixth term is the term which is independent of x, and it turns out to be 8c5 into 1 upon 2 raised to power 3. So on simplifying this, we get that it is equal to 7, because 8c5 is 8 factorial upon 5 factorial into 3 factorial. So simplifying this, we get that sixth term turns out to be 7. Next, suppose we have to find the term independent of x in the expansion of under root of x by 3 plus 3 by 2x square whole raised to power 10. So the problem is to find the term independent of x in the expansion of this. So here n is 10. So again we write the general term r plus 1th term. This is equal to 10 cr under root of x by 3 whole raised to power 10 minus r into 3 by 2x square whole raised to power r. This is the general term, r plus 1th term. 10 cr first term raised to power 10 minus r into second term raised to power r. So what we do, we will find the power of x. So this is equal to 10 cr. Now under root of x by 3 means this is x by 3 whole raised to power 1 by 2. So this is x by 3 raised to power 1 by 2 and whole raised to power 10 minus r, right? And this is 3 by 2 raised to power r into 1 by x square raised to power r. So now this is equal to 10 cr. Now powers will get multiplied, so I will get x raised to power 10 minus r upon 2 into 1 upon 3 raised to power 10 minus r upon 2. I have separated the terms x and 1 upon 3 into 3 upon 2 r. Now here it is 1 upon x square r. So it will be x minus 2 r, right? So powers here I get multiplied. I have separated x and 1 upon 3. So simplifying this, I will get 10 cr. Now I will combine the terms x with powers 10 minus r upon 2 minus 2r into 1 upon 3 10 raised to power 10 minus r upon 2 into 3 upon 2r. So this is the r plus 1th term. So we have to find the term independent of x. So what will I do? I will put the power this 10 minus r upon 2 minus 2r to be equal to 0. So by putting 10 minus r upon 2 minus 2r to be equal to 0, what will I get? 10 minus r upon 2 is equal to 2r. Now cross multiplying, what will I get? 10 minus r is equal to 4r. So 10 will be equal to 4r plus r, which is 5r. So r will be equal to 10 upon 5, which is 2. So what I have done? 10 minus r upon 2 minus 2r, I have put this to be equal to 0. So by solving this equation, I get r to be equal to 2. That means the third term is the term independent of x. So what will I get? T3 is equal to 10C2 1 upon 3 10 minus 2 upon 2 into 3 upon 2 square. This is the term which is independent of x. So, this will be equal to 10C2. Now, 10 minus 2 is 8, 8 upon 2 is 4. So, 1 upon 3 raised to power 4 into 3 upon 2 square. So, 10C2 is 10 factorial upon 2 factorial into 8 factorial. 1 upon 3 raised to power 4 is 1 upon 3 raised to power 4 means 3 into 3 into 3 into 3, 4 times. So, it will turn out to be 81. Now, 3 upon 2 whole square will be 9 upon 4. So, let us simplify this. 10 factorial. 10 factorial means 10 into 9 into 8 into 7 into up to 1. So, I can write this as 10 into 9 into 8 factorial upon 2 factorial is 2 into 1. So, 2 into 8 factorial into, now 9 gets cancelled with 81 9. So, 1 upon 36. This get cancelled with this, 2 5s are 10, 9 4s are 36. So, this will be 5 upon 4. So, third term which turns out to be 5 upon 4 is the term independent of x. So, what we have done, let us recall. So, the problem was to find the term independent of x in the expansion of under root of x by 3 plus 3 upon 2x square raised to power 10. So, here n is 10. So, we have written the general term. It is equal to 10 CR under root of x by 3 raised to power 10 minus r into 3 by 2x square raised to power r. So, on simplifying this, we obtained that r plus 1th term is equal to 10 CR x by 3 raised to power 10 minus r upon 2 into x minus 2r into 3 by 2r. So, we see that power of x which is coming in r plus 1th term is 10 minus r by 2 minus 2r. So, what we do? To find the term independent of x, we put 10 minus r upon 2 minus 2r to be 0. So, solving this, we get r to be 2. That means third term is the term independent of x, and that turns out to be 10C2 3 raised to power minus 4 into 3 by 2 square, and that is equal to 5 upon 4. Okay. So, next is, suppose we have to prove that the ratio of coefficient of x raised to power 10 in 1 minus x square 10 and the term independent of x in x minus 2 by x 10 is 1:32. So, let us see this. So, we have to prove that coefficient of x raised to power 10 in this divided by term independent of x in this expansion is 1:32. So, let us first find the coefficient of x raised to power 10 in 1 minus x square 10. So, we know the formula of r plus 1th term. Now, we have to find the coefficient of x raised to power 10. So, what will I do? See, r plus 1th term in this expansion is equal to 10 CR 1 raised to power 10 minus r into x square raised to power r into minus 1 raised to power r. So, I want to find the coefficient of x raised to power 10. So, here 2r, here I am getting x 2r. So, I will put r to be equal to 5. So, put r to be equal to 5. So, what will I get? T6, this is equal to 10c5 1 raised to power 10 minus 5 into x10 into minus 1 raised to power 5. So what will be coefficient of x raised to power 10? It will be equal to minus 1 raised to power 5 is minus 1 minus 10c5, that's it. 1 raised to power 5 is 1. So coefficient of x raised to power 10 in this expansion turns out to be minus 10c5. Now next we have to find the term independent of x in this expansion. So again what will we do? We will write the general term, that is equal to 10cr x raised to power 10 minus r into 2 upon x raised to power r and minus 1 raised to power r, right. So this will be equal to minus 1 r 10cr x 10 minus r into 2r. Now 1 upon x raised to power r will be x minus r. So this will be equal to minus 1 r 10cr x raised to power 10 minus r is 10 minus 2r, x 10 minus 2r into 2r. So to find the term independent of x, what will we do? We will put 10 minus 2r to be equal to 0. So put 10 minus 2r to be equal to 0. So what will I get? I will get 10 to be equal to 2r, that is r is equal to 5. So that means sixth term is the term independent of x. So T6 will be equal to minus 1 raised to power 5 10c5 into 2 raised to power 5. So this will be equal to minus 2 raised to power 5 is 32. So minus 10c5 into 32. So now what was the problem? Problem was to find the ratio of coefficient of x raised to power 10 in this expansion and the term independent of x in this expansion. So coefficient of x raised to power 10 in this expansion turns out to be minus 10c5 and the term independent of x turns out to be minus 10c5 into 32. So what will be the ratio? Ratio will be equal to minus 10c5 upon minus 10c5 into 32. So this will get cancelled. So answer is 1 upon 32. This is what I want to prove. So next is, let us discuss about the applications of binomial theorem. What are the applications of binomial theorem? Where is binomial theorem used? So suppose we have to find the value of 999 raised to power 3. So with the help of calculator it is very easy, but if we have to find its value manually, it is very difficult. So let us see how we will find this using binomial theorem. So what will we do? We will write 999 is equal to 1000 minus 1. So what is our problem? We have to find the value of 999 whole raised to power 3. So what will I do? I will use binomial theorem to expand this. So this will be equal to this cube minus 3c1 into 1000 square plus 3c2 into 1000 plus 3c3 minus 3c3, that's it. So powers of 1000 are decreasing, 1000 cube, then 1000 square, then 1000 raised to power 1, then 1000 raised to power 0, that is 1. So what will be this? Now what is this? This is 10 raised to power 3. Okay, so this becomes 1000 cube. Now what is 3c1? So see, 3c1 is equal to 3 factorial upon